Hi grade 10, this is Miss OD. So in this podcast we're just going to do two more trig equations, only a little bit trickier than the other ones that we've shown you so far. You're just using all the same sort of knowledge. So the first thing you need to remember is to decide which quadrant or quadrants the solutions will lie in. And for that we will use our triangle. All stations to central for those who have me, and I know Miss Hughes's class has a slightly different saying. So here we just decide, is sine positive, tan positive, cos positive, and so on. The next thing we do is we calculate the acute angle using the exact values if possible. So remember, if you see a 30, 60, or 45 degrees, you can use your exact values. And then finally, we find the corresponding solutions in the appropriate quadrants. And this is where we use the 180 minus theta or 180 plus theta or 360. So let's get started. And when you're solving these, don't forget just your basic equation solving skills, because you use a lot of those to solve these problems. So you perform the same sorts of processes. So here we have root 3 tan theta plus 1 equals 0. So we're trying to get theta by itself, and so we do what we would normally do with an equation. Let's get rid of any of the numbers that we can. So because it's here plus 1, that means I can subtract 1 from both sides. So I'll have root 3 tan theta now equals minus 1. And then remember, it's root 3 times tan theta. So again, using just your basic equation solving skills, because it's being multiplied by root 3, we would divide by root 3 on both sides. So now we're at this point, it becomes a much easier question. But the next thing we need to do is we need to work out which quadrants will our answer be in. So we have tan theta equals minus 3. So we go over to here. So the tan of the angle is negative. So we look, where is tan negative? Here and here. So in the second and the fourth quadrant. So that becomes important later on. Now we need to find the acute angle. So we now need to use our exact value triangles. Because I've got a root 3, I'm kind of guessing that I'm going to have to use that triangle. And because it's root 3, that means it's my 60-30 triangle. And remember, that comes from an equilateral triangle of sides 2. And by Pythagoras, that's root 3. So tan is opposite over adjacent. And I've got 1 on top. So 1 is the opposite side. So I see here tan 30, and 1 is opposite 30, and root 3 is the adjacent side. Remember, this is your hypotenuse because it's opposite the right angle. This is the opposite side, and this is the adjacent side. So I can see here tan 30. So remember, this is not necessarily what theta equals. Tan 30 equals positive 1 on root 3. Now we go back to the question and we want to know what theta equals. But we don't need 30 because 30 is acute, and we know that's in the first quadrant. And we didn't tick there because that's when it's positive. So I need the corresponding angle to that acute angle in the second quadrant. So it's 180 minus theta. So then I say to myself, okay, I know now when we say theta up here, we mean the acute angle. So I know it's 180 minus 30. And the other quadrant was the fourth quadrant. And I know in that quadrant, to find the matching angle, we always do 360 minus the acute angle. So minus 30. And then it's really easy. Just tidy that up. 180 minus 30 is 150. And 360 minus 30 is 330. So my two angles are 150 degrees and 330 degrees. They will give us an answer of minus root 3. And the other two quadrants would give us, in here and here, would give us positive 1 on root 3. Okay, let's try one more. So here we have 2 sine squared theta equals 1. Now remember to follow your basic equation solving rules. So I have 2 times sine squared theta. So let's get rid of that first. Because it's been multiplied, then I can just divide both sides by 2. Don't forget to keep that square there for the minute. And so when I divide this by 2, I of course get a half. Now here you just need to be careful because it's squared. And what you need to remember is when we write the squared in between the sine and the theta, it's actually the same as saying sine theta all squared. Okay, they are the same thing. So because we have something squared, just like if we had x squared, we take the square root of both sides. When you do this, be careful, because just like when we're solving equations, normal like algebraic equations, we take the square root. But when it's squared, remember this is saying something squared gives me a half. And you mustn't forget that negative numbers squares also give you a positive answer. So when we take the square root, I have to have plus or minus there. Now, when it's written like that, it might not look so obvious what you need to do next. So if we actually take, remember if you have a fraction, the square root of a fraction, we can take the square root of the top and bottom separately. So the square root of 1 is just 1. So we have just root 2 on the bottom. Now, hopefully you can recognize that when it's got a square root 2, probably going to need one of our triangles. Before we deal with that, whoops, we need to get our circle, and we need to figure out which quadrant will our answers lie in. So sine is positive. Let's deal with the positive part first. So that's an easy one. All of them are positive in the first quadrant. S stands for sine being positive in the second quadrant. And then if we deal with the negative part, here sine is negative because remember the t means only tan is positive. And here sine is also negative because only the cos is positive there. So we're actually using all 4 quadrants this time. Now, so we start with the easy part. We find what the acute angle is. So as I said before, because it is a root 2, I'm going to guess that I need my 45 degrees triangle. So remember that comes from a square of sides 1, and then by Pythagoras that's root 2. So then sine is opposite over hypotenuse. Remember this is your hypotenuse. Now because these 2 angles are the same, it doesn't matter which one you use. If I use this 45 down here, then that's the opposite and that's the adjacent. But if I use this 45, these 2 would be the other way around. It doesn't matter, that you get the same answer. So if I do sine is opposite over hypotenuse. So there's 1 over root 2. So hopefully you can see then that sine 45 is 1 over root 2. Now that's quite nice because we need the acute angle. This is the one in here. So now we can go straight to getting our answers. So I know one answer has to be 45 degrees because that's acute. Then I actually need the answer in the second quadrant. So I know in the second quadrant I do 180 minus 45. I need the answer in the third quadrant, so I know I do 180 plus 45. And the last one, I need 360 minus 45. And then the last step, just tidy that up. So I have 45 degrees, 180 minus 45 is 135 degrees, 180 plus 45 is 225 degrees, and 360 minus 45 is 315 degrees. So hopefully that's all clear for you, and good luck. Okay, thanks. Bye.